This next microscope is called a scanning electron microscope, or SEM. Annabelle, let's go to the lab again to see how to prepare samples.
Oh no, not again.
Just like the sample prep for TEM, samples for SEM usually need to be fixed and dehydrated.
This is getting old.
But after dehydration with solvents, the sample gets dried using a machine called a critical point dryer, or CPD. The CPD will replace the solvent with liquid carbon dioxide. It then adjusts the temperature and pressure until, poof, the liquid carbon dioxide evaporates.
Well, why don't you just leave a sample out to air dry?
When liquids evaporate from the surface of a sample left out to air dry, forces called surface tension can cause the sample to shrivel up. Using a critical point dryer avoids these distortions so that a cell will look like a cell rather than a shriveled up raisin.
Yeah, air drying totally ages me like 30 years.
After drying the sample, it gets coated with metals using a machine called a sputter coater. By covering the surface of the sample with a thin layer of metals, the sample is made conductive to electrons.
I'm so shiny!
We're now ready to use the microscope. Just like the TEM, the scanning electron microscope also operates in a vacuum, but rather than a focused beam of electrons being transmitted through the sample, they are scanned across its surface. The electron beam interacts with atoms a few nanometers from the sample's surface, causing these atoms to eject some of their own electrons called secondary electrons. These secondary electrons are then recognized by a detector and an image is formed.
What do SEM images look like?
SEM images show the surface topography of a sample, and they have a three-dimensional appearance.
These pictures are so cool. I mean, look at that. Those are way cooler than TEM images.
Hey,